And finally, part C. Part C says that we are given complex number root of 2 out of 3 plus root of 3i. Don't get scared. Just follow the steps. One, you said we let z be the complex number given as root of 2 out of 3 plus root of 3i. And then we need to find the magnitude of the complex number, which is r. So we say r is given by the square root of x. X is the real part of the complex number, which is root of 2 out of 3, but we square it, x squared. And then plus y. Y is the coefficient of I, which is root of 3. And then we also square it. Then you press your calculator. You have root 2 divided by 3 squared. Root 2 divided by 3 squared. Root 2 divided by 3 squared, I'm getting 0.22222. That is like 2 out of 9. So this gives us here square root of 2 out of 9 plus 3. Because the square root of 3 squared is 3 plus 2 divided by 9 is 3.22. And then you find the square root. I'm getting 1.7951 before the units. Even the calculator can press for you the whole of this at once. How do you press it? You press the square root, then you open two brackets. Open bracket again. And then you say root of 2 divided by 3. You close the bracket, squared. Plus, open bracket, root of 3, close the bracket, squared. And then you close the bracket again. Press equal sign. It's giving you 1.7951. So the calculator can do that for you when you press it well and you give it the right command. Then you come and represent the complex number on the Gann diagram so that you get the argument. This is the imaginary part of the complex number we are calling z. This is the real axis rather of the complex number z. That is the origin. Now from here we need to mark root 2 out of 3 and root 3. Which one is bigger? You can simply try on the calculator just to see. Root 3 is 1.7. Root 2 divided by 3 is 0.47. So root 3 is bigger. So we're going to mark root 3 further away from the origin, yes? But there is no penalty in how you put them, whether they are nearer to the origin or far, but be organized. And then on the real axis, let me mark somewhere closer here to root 2 out of 3, then correspondingly negative root 2 out of 3. Now we have drawn our complex plane. Now let us represent the complex number. The real part here is positive root 2 out of 3, which is here. The imaginary part has positive root 3, which is up there. So they are going to intersect approximately somewhere there. Please use a ruler so that you are guided better. This is the straight line. That is the straight line. So they are meeting somewhere here. So we draw a straight line from the origin up to where the complex number is with a ruler. And then you say this is my complex number that I called z. Now we need to find the argument. The argument is this value here. Is this angle that the complex number makes with the positive real axis. That is the argument. Now you need to extract this triangle to guide you, but I'm not going to extract that. I'll just know that from here up to here is the same as from here up to here. That means it is the same as root of 3, the same distances. From here up to here is 2 root 3. So this distance here is the same as, it is root 2 out of 3 actually. Now from there we need to apply our sine, cosine or tan. You choose. But if you want to use sine or cosine, you will be forced now to use the magnitude of the complex number, the hypotenuse, which is here. And we shall get the same answers. So let me go with our usual method of using tan. So that we say tan of angle theta becomes the opposite, which is root of 3, divided by the adjacent, which is root 2 out of 3. If we apply the laws of division of fractions, we shall have tan of theta becoming 3 root of 3 out of root 2. Yes. And then now you say therefore my theta becomes the tan inverse or arctan of 3 root of 3 divided by root 2. And the calculator will do that for you. You press tan inverse, which is shift tan, then you open the bracket and say I have 3 root 3 divided by root of 2. Close the bracket. I'm getting 74.77 degrees. Let me confirm 3 root of 3 divided by root of 2, tan inverse of the answer. Yes. So this is our argument theta. After getting argument theta now, then you say from the polar form given as z is r into cos of theta plus I sine of theta. That means here we substitute for r, for which r is 1.7951. Yes. Then you open the bracket and say cosine of the angle 74.77 degrees plus I sine of 74.77 degrees and close the bracket. That is the modulus argument form. Or you can use the other alternative that the polar form is given by r, theta, for which r is the same 1.7951, what is the angle? It is 74.77 degrees. This is also correct. This one is correct. So that is how we solve this example